Hey, what's up, everybody? It is Astronomy Daily Live, and here we are again. So come on in, join the circle, and this might be a this might be something new today. I'm gonna um, see if I can get a panelist on. Bobby Burgess has requested that I get him on as a panelist. So I'm gonna go see if I can do that. All right, Bobby. Um, shoot, how can I do this? Okay, hold on. I need to get into my mail. My Google Mail, my Gmail. Maybe is it? Oh, it's already me. Yay. All right. So, Bobby, if you're there, are you there? Yeah. Hey there, Bobby. So, I'm going to send you the link that I have on my screen. Copy. And I'm going to paste it into a reply to you. And let's see what happens. Let's see what happens. So yeah, come on in, everybody. Gather around. Our intro was in the chat before we even started. So hey, nice to see you again. Hope everything's well. Oh, I forgot any kind of liquid molecule. Huh. Hmm. Might have trouble with that. Might have trouble with that. I don't know. Huh. Maybe what I should do is take 30 seconds right now and there he is. I see something. Yeah. Hey, cool. I'm gonna put my I'm gonna put my headphones on. Hey, Bobby.
Hey, what's up?
Hey, what's going on?
Hey.
Network is terrible over there, huh? Our intro. Hey, I I was just saying that I need to go get something to keep it fluid. So I
At the
think
back here.
I'm gonna go do that. See, look at that. So I'll be right back. I'll be right back, like 30 seconds.
At the back here.
Dude, I cannot tell you how easy that was, and so cool. So very cool. So cheers. This is the hydrogen hydroxide, HOH. It's an acid and a base at the same time.
Dude.
Fabulous.
Yeah.
All right, very very cool. I think so. Yeah, come on in, everybody. Come on in. I'll give everybody a few more minutes, and then we're gonna fly. Who's gonna fly? I'm gonna have to mute that. Okay. Yeah. When I have a panelist on, it's well, we'll see how this works. I'm not exactly sure, how this bandwidth thing works. You're gonna have to get used to me wearing headphones instead. So yeah, that's how it goes. All right, yeah. So our instro is saying, Bobby, that he's getting some feedback. So if you can mute your audio, unless you want to, chit chat, uh, then of course turn it on. Now I think I can turn you off too. I think I have that ability. Yeah, so I can mute you too. So I'm going to try that. All right. There. I think Bobby is muted now. So, and I think maybe only I can unmute him. So let's try that. Whoop. How do I? I'm not quite sure how to unmute you. Will you try to unmute yourself? Yeah.
Testing 1 2.
That works. That works. Cool. Very, very cool. Okay. And then I can switch between me and you, or it will do an automatic thing of, I'm not exactly sure how that works though. So, all right. I'll just let that go for now. So, yeah, this is very, very cool. Yeah, I've been wanting to see how the panel thing works. And yeah, I think that's very, very cool. Yeah. Let's reserve the reverb for, space music. So I saw a post today. It was a tweet that said that the entire Rosetta mission, all the images had been posted, posted, and so I went on over there, and lo and behold, yeah, there was a little thing about that. I'm going to share my screen. Now, I don't know how the sharing of screen is going to work with a panelist, so
Hey, Eduardo.
we will see. Hey there, Ata. Atawahinta. All right, so I'm going to share my screen, or at least attempt to, and see what that does.
Hey, Eduardo.
See what that does. We have our infinity screen here, which I like. I don't know about you, but I really like these infinity screens. I think they're great. I think they're awesome. I can make this a little smaller so we can really start moving it around and stuff. Yeah, I'm getting a little weird. Uh-oh. All right, I'm getting into trouble. Okay, so I posted the link over in my over on my Discord server. So here it is. Here it is. And it actually came out, I guess, like on the 21st of June. So, but this is the first that I'd heard of it. So what I thought I would do is just, you know, sort of dive into these images and just, you know, think out loud and uh, see what we see and look around. Yeah. And actually, what's really cool is that the image format, you know, the actual scientific data, uh, um, uh, is available, and it was some very simple software. I was able to read them in um, and be able to view them and all of that. So I've got access to the raw, well, I guess the calibrated data, all these images, right? So I'm pretty excited about that. But what I did is I just went over here and it's kind of weird how they did this because at first it's like, wow, what? There's only two albums. And it's like, okay, well, let's see what the two albums are. So you click on that, and you get uh, an album called Osiris and an album called Navcam. So Osiris is the high resolution imager on what was Rosetta. Um, and the Navcam was just a lower resolution, as the name implies, a navigation camera. Stream session is now audio and video. Okay. So let's look at the high resolution ones. And so there's two albums in here. So there's the cruise phase, which is the, you know, from essentially launch to orbit insertion, as they say. And then they have a comet phase. So either of these is pretty interesting. I think didn't it go by another comet? Isn't that what that is? I don't remember now. But I don't know. Let's look at the comet phase. So this is when it was in, you know, a common orbit with Comet 67P. So there's a pre-landing phase and a post-landing phase. So, you know, the pre-landing phase was when they were trying to figure out where to land the little probe, right? What was that? What was that little thing called? Uh, the name is escaping me at the moment. Don't remember. Philae. So, you know, they had to figure out from images and from, I think is there some kind of radar or something on this? I'm not exactly sure. Uh, I'd have to look and see what the instrumentation is. Yeah, Philae. Yeah. Um, so, you know, but they were using their instrumentation to figure out where they wanted to land, right? That was like, you know, the big deal. So that's pre-landing. And then they've got post-landing where, once Philae was finished, the orbiter was going to, be around this comet nucleus for several months, right? And so they wanted to study it. And that's what they did. So let's look at the thing. Everybody's sort of seen all this stuff, right? Yes, it's extremely cool and extremely interesting, but I I like to uh, I like to go where others haven't necessarily gone very much. So let's go to the pre-landing phase. They're going to have some pretty seriously high edges here, right? So no problem. So there's, and I don't know. You know, these ones look like they're still pretty far out. This one looks totally overexposed. Isn't that kind of funny? Let's look at that one. So now there's a so there's an OSIRIS NAC and an OSIRIS WAC. So that's a narrow angle camera and a wide angle camera. So, I don't know. Look at that. There's more narrow angle camera images. 1,097 of them. So let's take a look. Let's go through some of these and just take our time, wander a little bit. I'm not sure if that's the comet or if that's a star. Could be they were snapping lots of pictures. I'm not quite sure what we're here. I think we can click on any of these and get a little page describing it, maybe a little bit more, not much. Pre-landing, 27,000 kilometers away. 27,000 kilometers. So that's probably it. That's probably it. So, all right, let's, so we're slowly watching the approach here. 1,097 images. You can see that some of these have internal reflections, just like regular cameras. That's what they are, more or less. Regular cameras in a pretty special place. Must have been a pretty exciting time to be, watching these images come in, and somebody out there.
I'm still here, Cosmic.
What's that?
I'm still here.
Oh, cool. I'm glad. Very, very cool. Cheers. And feel free to chime in anytime, Bobby. As I said, this is just I'm just the host here, so feel free to pop in any time. I was just thinking about the first person who saw these, and Yeah, I'm incredibly jealous.
So these are like the Rosetta kinds, right?
These, yeah, what you're seeing there, right, it is the narrow angle camera um, looking at the comet from a pretty good distance, right? But we're starting to see a shape here. So let's just see how far. So they were about like 12,000 kilometers out still. So just starting to see a little bit of a shape there, right? And let's see, when was that? That was, it looks like July 14th, 2014. So yeah, I I don't remember when I don't remember when uh, um, orbit insertion happened. I don't remember exactly when that was. Anyway, let's keep let's keep going here. See where we end up. Looks like they've got a couple of different options when it comes to this camera, right? It looks like they can obviously, they can change the exposure time, but it's sort of looking like, this is very much zoomed in and this is very much zoomed out. I don't know. Lots of internal reflections and weird looking things. That's real data for you. Messy. Real data is just a big mess. Amazing that we get anything out of it at all. But yeah, it would have been nice to be the person who first saw these, and it's like, what is going on? And a lot of
How
these
many
images.
images we're gonna see on this page?
What's that?
How many images we're gonna see on this page?
There's a lot. There's like 1,097.
Dang.
You can see a lot of the images are, I mean, almost what I would call garbage, right? I mean, that, how useful is that? Probably not very much. But what we should be seeing, if this is sort of in a sequential list of time, it should be appearing to get larger and larger and larger. Of course, they can probably change their zoom, but well,
And what
let's
are
see.
the time frame of these images?
Like exposure time.
I mean, like the time frame from the start of the images to the most recent.
Oh, okay, yeah, I think we'd have to look at the first one and the last one to know that. It's probably um, it it's probably, I would say, just a guess, um, based on the fact that there were like eight albums there. Um, if there's one album per month, that's probably about right. So this is probably a month's worth of data. And let's see, these are 25-second exposures. So pretty overexposed. You could start seeing a little bit of a shape there, but I would call that sort of overexposed. You'd have to look at the actual raw data, which is this thing right here.
Anawada is asking how often those images are taken.
Yeah, I think, let's sort of take a look here. So this is July 22nd at 0:45. Okay, so let's look at the next one. Oh, I don't know which one it was. Okay, here, let's do this. Let's. Okay, I'm going to look at this one. And that is 0044. So 4424, say. Okay, that's when that was done. The next one over. Uh-oh, I went too far. The next one over. $34. So that's 10 seconds. Yeah, so maybe I'm not sure. I'm not sure how much of a time span then. Not exactly sure, Uncle Bill. Not sure. All right, well, let's keep going here because there's a lot of them. There we go. So I think they probably have the ability to zoom in and out. So I think that's what they're doing because, I mean, obviously if this is a sequential thing, it's not going to get bigger and then smaller and then bigger again. So they probably have some kind of zoom on this thing. But these, I mean, at this point, right, everybody's mind is just getting blown. Because it's like, what is that? That's just crazy. Oh, pretty crazy, wild looking thing. Whoop, I went too far again. This old laptop is seeing better days. I tap on the pad button, and it almost always registers a double hit instead of a single hit. And so, yeah, it's just crazy. These problems that we first worlders have, But yeah, I don't know. Let's take a look at the times of these. So the big ones here. See if there's a 10-second difference between these two. So 3032, 3032, and oh man.
Are these photos taken from a probe or from a telescope?
These are taken from a spacecraft that named Rosetta. That actually went there. But the images themselves, of course, are taken with a telescope, but on the spacecraft. So 5005. So I think that's something like 15 minutes, right? The other one was 35. I hear doggies in the background. Oh, 30. Okay, so that was like 20 minutes between those two. So yeah, the time in between all these isn't consistent. So yeah, if it's a month's worth of data, then what? 1,100 images would be about. Let's out the calculator here. 1,100 divided by, let's just say 30 days in a month. So that's 36 per day. So yeah, that's a believable number. So let's keep going here. We're seeing more detail. Yeah, that's a nucleus of a comet. So it's not a very active comet. It doesn't really get incredibly close to the sun. That, you know, uh, these things can get pretty active, and they wanted to be able to study this thing uh, as it approached the sun, and then got as close as it did, and then as it moved away. And I think, oh, Uncle Bill, you might know this. What was perihelion for 67P? How far? I mean, it was more than I'm pretty sure it was more than one astronomical unit. I want to say maybe it was like two or so, 2 astronomical units, 2.5. I don't remember. So I mean, it didn't really get incredibly close to the sun, but it got close enough to show some activity and uh, hopefully provide sort of enough data to fit into their models so they can see if they can understand what this thing is doing. But lots of surprises, lots of surprises. It's a big rock. Thought it was going to be a big iceberg, and it's not. It's a big rock with sand dunes on it and boulders and signs of um, avalanches. So it's surprising everybody. I'm not quite sure what these are. Not totally sure. I mean, unless they're you know just putting the comet out of the field of view to maybe catch some of the so-called outgassing. Don't know. Look at that one. Oops. See, now at a telescope that would be called like a foot binary or a foot smudge, because that's what happens when you're taking an exposure and you bump your foot against the uh, the mount. So yeah, the I think the little green guys out there, you know, must have accidentally bumped against the spacecraft. My only explanation. Oh, there's another one. So a lot of these look really overexposed. I'm not quite sure why they were doing that. I mean, you know, you have to know that every single one of these images is intentional, right? They're not really making a lot of mistakes. I mean, I think these kinds of things are probably mistakes, but uh, you know, overexposure, I think that's probably planned. They're looking for something, right? So they're going to set the exposure time accordingly. Yeah, I'm sort of thinking that they're doing really long exposures here and just looking at one edge, to see if they can see any activity. Let's see how long the exposure time is here. 2.2 seconds. Okay, well, that's not very long, actually. So I'm not sure. Maybe that's a star. I don't know. Does it say? It doesn't really say. Getting really close, though, right? 1.5 kilometers. Isn't that about a mile? Okay, 1.24 astronomical units. That's a little bit closer than what I thought. But okay, cool.
Is it possible that the more exposure time, the better the picture, or what's the difference?
Well, I guess it depends on what you're looking at or looking for, right? I mean, if you just overexpose, then it's pretty useless, right? This, uh, you know, that looks overexposed to me. So I would say that's just junk. I have absolutely no idea what they're looking for there. I mean, one can only assume that that this was a planned exposure. But yeah, to me, it just sort of looks like it looks like a mistake. I don't know. I did it again. That laptop troublemaker. Oh, cool, cool, Orange Joe. I hadn't heard about that. It's called Ambition. Okay, is it on YouTube? I'm gonna do a search for it here on my Linux machine. Ambition. ESA. It doesn't, unless it's really really short. Is it like 6 minutes and 40 seconds long, or uh, is there a longer version? Because I've got this one. I can let me post this in the chat.
Yeah, our Astro wants to know if he can link it and stuff, but I think you got to be a moderator in order for that to make it work.
Yeah, you got to be a blue man. I think it's this here. I'm gonna post it. I think it's this. If you can confirm that, our instro, that would be very cool. So cool. I will check that out, but I'm going to keep looking at these images because there's a lot of them to go through. And I mean, I think that for the most part, these are very un, you know, not very interesting, right? So it's sort of like, when's he going to move on to the good stuff? But I would think in some way this stuff is useful. Don't know. Don't know what they're doing. This might be part of the calibration process. Seeing some funny patterning in here though, so it's probably electronic noise of some sort. Hard to know. Don't know what's going on there. Yeah, hard to know exactly what they're up to here. That's probably a cosmic ray. It's the most exciting thing I've seen so far. Let's see. A bunch of gray squares. There's a couple of shots of it. So
Those gray squares are usually mean wasted shots, right?
I you know I I have to I have to hope I have to hope that all of these like blank um, images uh, were taken for something. I don't. I have a hard time, believing. I guess that you know uh, they would be like, oops, oops, oops. They keep pushing the button, but oops, oops. Yeah, I don't think so. My guess is that it's probably calibration. Probably.
It's either that or they're doing it on purpose.
Yeah, for something. For something. All right. Well, that really wasn't the most exciting thing I've ever seen. Let's go back to let's get a little bit closer to the time that they were going to land this thing, which is probably this. Now I know that we're supposed to be talking astronomy here, but it's going to be talking rocks. So there's a narrow angle and a wide angle. What do you think? Wide angle? All right. Okay. Thanks. Thanks, our instro. I mean, if you want to put that over on Discord, that would be awesome. These are pictures? Yeah, these are actual pictures here. That's kind of a that's pretty cool. You got the foreground here and the background. And look up here, the oh no. Yeah. Unfortunately, the previews, this is all you get, so it sort of sucks. But look up here. Look at this. Look at this bright stuff. Really bright in the dark part. So what is going on there? I don't know. Am I going back? Am I going back? Back. Yeah, it's considered. Here it is again. Here it is again. Even here. So wow, what? I don't know what is going on there. That's a little weird. Have these bright spots in the dark like that? Pretty amazing place, though. Gotta say. Just absolutely fabulous. This was a 0.162 second exposure. So pretty short exposure, you know. I mean, considering that it's a pretty dark object and yeah, pretty far away from the sun, you know, pretty short exposure. 10 kilometers away.
How far did that spacecraft have to go to catch this object?
Oh wow. I think Rosetta. Let's see if we can find that out. I don't remember. It definitely. What I want to Google it. Definitely want to say it had a long path. Rosetta mission. Yeah, it was quite a ways. I know that. Let's see if we can go. Just where to look. About the journey. Probably about the journey. About the journey. Come on. It's trying. I think it's trying. A long trek. a long trek. And okay, so well, let's see.
Hey, Cosmic.
Okay, so, yeah.
Hey, I got called to go to the store. I'm gonna
All
try to
right.
watch the feed on my phone. So yeah, if you're still on, I'll come back. Okay.
Okay, cool. Yeah, I'm probably only going to be here, another 15 minutes or so. But this is so cool that this worked so easily.
Yeah, I
So
liked it too.
yeah, very, very cool. So yeah, I uh, I think having a panel uh, would be would be really, really great. So I think it would add a really, really nice dimension to this, and not have to have me out in front all the time, right? I mean, I don't need that. So yeah, I think uh, this is great. I'm glad that it works. So yeah. But as I said, yeah, I'll probably only be on another 10 or 15 minutes or so. Who knows? But probably. So yeah, thanks for coming in, Bobby, and I will see you later. All right, cool. Well, let's look at this anyway. um, so so March 2004 was when it was launched. Okay, then um, it had a Earth flyby in 2005. So it went all the way around the sun once, came back to Earth, got a boost, um, went to either Mars or Earth first in 2007, and then the other one. And then it had a third encounter with Earth in 2009. So that's pretty crazy. Mars flyby, asteroids. So it did. It actually went by two asteroids, Steins and Lutetia. Okay. Um, then it went into hibernation from May 2011 to January 2014. Cool, Bobby. Nice to see you there. um, and then it wakes up on the 20th of January, and in May 2014, uh, and actually arrived at the comet on the 9th of August 2014. So it was launched uh, in March of 2004 and got to the comet in August of 2014. So over 10 years. Over 10 years. Yeah. Well, you know, that's uh, that's what happens when you don't have enough fuel, right? You've got to use these gravitational assists, and gravitational assists take time. You got to go uh, you got to go around the sun so many times. It's a long way. Yeah, so cool. Let's keep going here. Oh, there we go. So I just like the fact that they've now released all of their image data, and I'm pretty happy that I can grab the raw data. I like it. There may be things that I want to do with that. Who knows? Pretty cool. Pretty cool. Yeah, that was the long way, all right. Obviously, different exposure times. A little overexposure there, it looks like. Pretty fabulous. That was awesome. I wish we could look at the full um, full resolution image because it's 2048 by 2048, not this little thing. But this thing does not allow us to do that. Well, let's try this. So let's save it. And then we're going to look at it. Show in folder. It's got to index every single time I go into this file. It has to index things. It drives me crazy. Oh, it's not quite done yet. 2 seconds. There we go. There it is. Now we can look at it full res. There we go. That's a little better. Take a good hard look at these cliffs. Wow. Lots of pointy things. Look at this. Look at that. That is huge. Pretty strange looking place, you know? Look at these cliffs. Just crazy. Pretty crazy. I like it. See, we do that. Let's look at the knack. Bet you they got some pretty high res images here. Oh yeah. They can underexpose too, which is a problem. Lots of boulders. Lots and lots of boulders. Should we take a look at one of these? Whoop. So I can save it, I guess. "45 seconds. We can keep looking while that's downloading. That's a pretty cool shot, you know? Wow. Take a look at that too. It's a little funny looking, you know? Okay, I think this one's done. Look at those, look at all those boulders. Let's start over here. So, you know, you're seeing a lot of shadow here, right? A lumpy place. Look at these lines, cracks. Oh no. Look at these boulders though. Look at that one. Huge, weird looking things. Look at that. There's really bright spots. See that? Where it's really where they're it's actually overexposed. It's shiny. Lots of shiny here. Look at all the white. There's more over here. Yeah, lots of shiny, either shiny stuff or really flat. So cool. This one's done. See you later, Ata. Nice to see you in the chat. So excited about hearing about your scope. That is very awesome. Wow. That is a really cool shot. Isn't that a cool shot? I mean, those are real cliffs. Look at that. Holy moly. That's great. There's a little thing here. I don't know what you'd call that. A little rock sticking out. Some boulder over here. That is a crazy picture. That is just crazy, isn't it? Look at this up here, these weird cracks. Yeah, yeah, yeah. Yeah, you know, I can't know what the scale is here. Don't know how high that is. It's got to be pretty high though, right? You got to think it's got to be pretty high. It's not going to be, you know, a couple inches, right? I mean, it's going to be pretty sizable. Yeah, I don't know if it says anything about. Yeah, it doesn't give resolution information here. You know, how many meters per pixel or whatever it is. But that's a crazy shot. That's pretty crazy. Look at these boulders. Take a look at one of these. Well, that is the intention of this live stream, is to blow your mind. So I'm glad that I'm accomplishing that in an indirect way. Keep looking while that's downloading. Look at these weird cracks. I just want to look at them all. Here again, look at how bright and shiny that is. That's just weird. I don't know what's going on there. Is this the other node, the other side of it? It's being blocked. So this is like in shadow. Huh, it's kind of strange. Wow, that's just incredible images. Oh, I gotta download that one too. Yeah, this one's done. Don't remember what it was. Oh yeah, the boulders. Look at all those rocks. And you got it. I mean, you know, there are dark ones, there are light ones. It's really interesting how reflective, how bright a lot of these surfaces are. That's intrigues me a little bit. God, look at that. Look at that weird shape. Wow. That is really pretty amazing looking. Isn't it great that we can do this? I mean, not only great, you know, that we can send a spacecraft there and study it and everything, but we, as in you and I, can sit here and look at this thing and just amazing. Those little cracks. Now, this has got to be pretty small scale stuff. I mean, centimeters for sure. It's got to be. Look at that. Look at that bright, weird looking thing. There's another bright one over here. Wow, look at that. That's pretty funny looking. What is that? That is really weird looking. But you know, our brains are so good at finding things. I mean, look at this weird pattern. It looks like fingers, you know? And man, I don't know what I'm seeing there. Two two dark, kind of thin looking things that shouldn't be up like that. And then this lighter, weird looking tube thing in between them. It's like, what is going on? Yeah, it's a little weird. Start at the top or the bottom. I don't remember. Pretty fabulous, though, you know? Okay, I think, was that this one? Yeah, I think so. Yeah, yeah. Well, I wish I knew what the scale was here. our intro. That would definitely change my tune. Nice long shadows. Sun is at a very steep angle there. Shallow angle, I should say. Yeah, I think it's absolutely fabulous that we can do this. We can just sit here and, you know, see this kind of stuff. It's great. More boulders and or pebbles. Look at this weird looking thing. It's just weird stuff. Excuse me. Yeah, that's a little weird looking. Don't know what's going on there. Boulder field here. Look at that. Isn't that fantastic? Nice flat surface here. I don't know what's going on here. Look at that. Weird landscape. Yeah, very cool. So I think we're almost done with this album. Oh, that looks absolutely fabulous. Take a look at that. I always go too far. So, well worth the trip, I would say. Took New Horizons 10 years to get out to Pluto. So, thing didn't have to go that far, but it used a lot more help. As I recall, New Horizons did have an Earth flyby and a Jupiter flyby. Have any other flyby? I don't remember. Oh, it's some pretty spectacular looking stuff. You know? Wow, that's. I mean, I know it's sort of just the lighting, but it's really cool looking. Quite an amazing object, for sure. I'm getting to the end here, I think. Like a bunch of maybe calibration images. They're looking at stars, star fields. Good way, to calibrate photometrically, right? As you look at a star, you know how bright it is, and you take a bunch of exposures, it's like, okay, well, a tenth of exposure on a, fifth magnitude star is going to produce this many counts on my CCD camera. And so that is directly relatable to the number of counts inside of an image then. That's pretty cool looking too, huh? Oh, there's too many. Did we look at this one? Oh, that's that one, yeah. Look at these. Look at this. Amazing. Just catching the sunlight. Is that great or what? Looks so unreal, you know? Look at these over here. Don't know what that is. But yeah, that's a sand dune. Sand dune on a comet. It's a sand dune. So they never said anything about sand dunes on comets. They called them snowballs. Dirty snowballs. This is the this is like the furthest thing from a dirty snowball I've ever seen. Well, whatever you want to call it, it's fabulous. All right. Well, here, let's try to get through the rest of this album and then we'll call it. I will call it. Although I want to look at more of these with you, but we got to be mindful of the time. So, definitely appreciate you all coming in here, spending some time just, you know, forgetting about everything else and focusing on something astronomical, something spacey, something to, sort of, bring out the kid and just be just in awe. There we go. That's the end. And that's what I am. Boy, this stuff just blows me away. Pretty awesome stuff. Pretty awesome, awesome stuff. All right. All right. Well, I'm going to get out of here for now. So take care, everybody. And yeah, it's I mean, we think our instro. We think that we have everything sort of basically understood and everything else. And I got to tell you, it's the same old story. It's the same old thing. Every um, era has had this idea that it's like, oh, this we understand it. This is how it is. And comets and asteroids are going to change. Are probably going to change our attitude about lots of things because if 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 the story about comets and asteroids is not true, is incorrect, has been misinterpreted, then basically everything else um, is also questionable and subject to debate and revision based on new knowledge. And that's what this is, right? This is trying to gain more knowledge. We can't be uh, we can't be so certain about things. It's just that's not what science is about. Science is about inquiring, trying to figure things out. Bobby came back for a quick howdy do, but I'm just exiting these waters. Yeah, so I'm going to get out of here. I was just, yeah, just you know, doing the ending soapbox, which I will now jump down from
Take
and
care, Cosmic.
exit these waters. So take care. I will definitely see you tomorrow, 2 hours UTC. Um, Make sure to subscribe. Make sure to thumbs up or thumbs down, whichever you desire. Make some comments. I like to see comments. That's
Take
always
care.
fun. And take care. Thanks, Bobby, for coming in. It works great. I like it. I want to see a whole line of panelists under here. Yeah. Now, for some reason, I don't. Can I? I guess the one thing. Okay, I guess I've got to do that. Whoop, I got to do that, and then it'll switch to you, I think. I don't know how to turn it back on to voice activation, so I'm not quite sure how that's done. But anyway, it is very, very cool. So peace, all of that. And I will see you on the spin. Now don't get dizzy. Don't get dizzy. It's pretty smooth. No big deal. But I will see you on the spin, one spin of this tiny little planet. So I'll see you in a little less than one spin. All right. Take care. Bye.